check the mic and make sure it sound right, boys.
Hello, my name is Muhammad Hurikan. I'm from Universitas Indonesia and I'm working as electrical engineer in the team.
Good day everyone, my name is Bagas. Currently, I'm responsible for the technical division of our ship.
Hello, my name is Gemilang from Universiti Indonesia team. My job desk is to design and manufacture the structure of the boat.
Hello, I'm Rizky Rifali Ramadan from Universitas Indonesia team, and I'm here responsible for the program we use for our boat.
It sound right, boy.
The NECA 0016 foil shape is used as the hull type of our boat. The shape is implemented primarily because of its low drag coefficient between 0.1 and 0.8 in interval of angle of attack from 0 to 30 degrees. Thus, there is a significant impact to the resistance of the hull. This impact actively enables the boat to go faster and smoother despite of its limited motor capability. In addition to that, the utilized hull arrangement in our ship is one of a kind trimaran type. The hull arrangement itself followed the ratio of R per L roughly equal to 0.3. That is the ratio of longitudinal distance between the bow of the main hull and the bow of the side hull divided by the total length of the boat. It also followed the ratio of S per L roughly equal to 0.4. which is the ratio of the transversal distance between the center line of the main hull and the center line of the side hull, divided by the total length of the boat. That is why we decide that the length of the main hull and the side hull is 200 mm and 140 mm respectively, with the uniform height is circa 100 mm.
Moreover, the hood is designed to have hollow compartment in order to make it lighter and more buoyant. Besides, the main material we use to manufacture the hood is PLA plus fireman, due to its sturdiness, lightweight mass, and affordable price. Next, we fabricate the tree hood by using Clarity Ender 3, a jack of all trades yet economical 3D printer. Additionally, for the top freeboard which the ethical components are placed, infraboard, that is a corrugated or twin-wall plastic sheet, is adopted. This plastic shield is employed on account of its low weight to volume ratio, about 0.946 gram per centimeter cubic, and waterproof characteristic. The latter is proven to be pretty useful to safeguard the ethical components from the water, while the latter is made impossible for the boat to be lighter. Lastly, each of the propeller is equipped with a 3-blade fan. This well-thought-out decision directly enables us to further improve the full throttle forward as well as reverse thrust of our boat without changing into more expensive, higher power consumption, and heavier thrusters.
The control system of our ship is based around one of Expressive Systems chips ESP8266. It is an inexpensive, energy-efficient, wireless fidelity microchip with embedded transmission control protocol or Internet Protocol networking software as well as microcontroller capability. The first reason we choose this solution over common 8-bit AVR such as 80 mega that one can be found in Arduino series is it has a high performance watt ratio CPU like Tensilica Diamond Standard 100 Micro, a 32-bit reduced instruction set architecture microprocessor whose default clock frequency is 80 MHz, while the overclock one is 160 MHz. With such CPU specification, ESP8266 enables us to develop complex algorithms that can be processed with a negligible duration and our ship to perform way better than ever possible before. Furthermore, the chip has a generous amount of random access memory, about 32 KB for instruction, 80 KB for user data, and 16 KB for system data. Hence, the microchip can run many tests in parallel swiftly. In addition to that, it contains 4 MB QSPI flash, thus the microchip can load a lot of programming codes without breaking any sweat. Last but not least, it has a minuscule dimension and lightweight mass. Therefore, the ship can be manufactured with a great velocity, high maneuverability, and compact design in mind.
The SP8266 is controlled manually via the Bring application. on a smartphone by means of WLAN or Wireless Area Local Area Network Tethering Connection technology. After receiving commands from the smartphone, the microcontroller will send pulse width modulation or PWM signals to the motor driver lock is 4 of 9 digital pins. The authorized motor driver is based on efficient 2H bits L298 and integrated circuit or IC. Furthermore, 2 low-cost LP106 motors are used as thrusters of the ship as specified by the competition organizers. Each of them is connected to the reservoir ports of the motor driver. By L298 and IC, we can change the direction of rotation of the motors as well as manipulate the rotation per minute or RPM of them easily. Moreover, the power consumption of the overall component is wholly fulfilled by the battery that we use, whose specifications consist of 7.4 voltage, 25 discharge rating, and 1100 mAh capacity.
In a nutshell, it can be concluded that electrical design of the ship has great performance to price ratio, solid setup, and straightforward fabrication. By integrating high-performance microchip, low-power consumption motor driver IC, and modular secondary as well as tertiary component into the heart of the ship, it is a fine example of a well-thought-out miniature boat.
As it was previously mentioned, ESP is implemented as the primary control system of our boat. ESP itself, from the point of view of a programmer, is a reprogrammable microcontroller that can be easily developed as one's desire. The main tool that is used to program this control system is Arduino IDE, a powerful application that is compatible with a lot of microcontrollers and has shallow learning curve. The programming language that is chosen to interface with the chip is C++. In addition to it, being the default language of IDE, C++ is a lightweight language which is optimized to run on low-resource machines such as an ESP, thus making it the ideal programming language for our needs. Furthermore, the purpose of programming convenience, ESP, Wi-Fi, and Blink libraries are used. The former provides the programmer with ease-to-use function, whereas the latter enables the microcontroller to communicate with the cell phone as the remote control of the boat. Moreover, for the graphical user interface, commonly abbreviated as GUI, Blink application is used the primary interface of our boat. The Blink app can be directly downloaded into any Android and iOS smartphone, hence making it a versatile solution for our requirements. The app itself has an embedded drag and drop feature, thus the GUI can be developed within a short amount of time. By using Blink and its library, the connection between our phone and the microcontroller, thus the boat can be established with ease and reliable network strength. In drawing things to a close, 3 virtual pins are utilized to communicate between devices. These pins are used on our program to help the pilot navigating the boat. The first pin is used to move the boat forward. In example, running boat propellers at the maximum speed to achieve the best acceleration possible, whilst the rest are utilized to navigate the boat to the left and right direction. The speed of boat propellers when turning itself is configured based on the finest result of the countless test attempts by our team. This experiment and eventually the conclusion that we deduce from it fundamentally are needed so the boat won't overturn, sink, and counter-turn when it is turning in the desired direction.
Enggak. In a nutshell, it can be concluded that our boat has a great performance to price ratio, solid architecture, and strike for development. By integrating inexpensive, high performance, and low power consumption components, modular as well as compact design, and intuitive control alongside advanced algorithms into the very heart of our ship, it is a fine example of a well-thought-out miniature boat. And that brings us to the end of this presentation. Thank you for your interest and attention, and adios! Good day, everyone. My name is
My job desk is, and I'm from Universiti Malaysia team Ulang.
Egem kelihatan kan ternyata. Yang lama.